Our next speaker is Giorgio Siringo. I hope I didn't butcher your name, from ISA and ALMA. Please take it away, Giorgio.
Hello, everyone. Good morning. So, do we see the slide? No. Okay. Right. So I work at ALMA in Chile, operations of the ALMA radio telescope, and I'm here in my role of spectrum manager for ALMA. Yeah. So I will start to some I know that there is a pretty heterogeneous number of people here, so I will try to give a quick explanation of what is ALMA. So it's the Atacama Large Millimeter Submillimeter Array. It's an interferometer, and it occupies the spectrum in a range which is called millimeter submillimeter, which is between the radio, classical radio, and the infrared. I added a picture of the sun and the human eye. I was motivated yesterday by the talks we heard about in indigenous people, astronomy, and so on. So just to remind that we genetically we are done in a way that with our eyes, we look at the spectrum in the same range of frequencies where the sun is emitting. But we don't see all the rest. So when we look at the sky, we see the stars with our eyes, but we are missing all the other emission that comes from stars, other objects in the sky. We don't see that, but it's there. So, does it move? Maybe like this.
Set the center button.
Yeah, the center button. Yeah. So ALMA is an interferometer. It's actually a combination of 3 different arrays. And we have a large array of 50 antennas, 12-meter diameter. They can be moved on the site up to 16-kilometer baseline. And then there is another, this is the yellow circle. It's another interferometer inside the interferometer, which we call the compact array, which is made of 12 antennas, 7 meter in diameter. And then we have another group of antennas that we use as single dishes. They are also 12 meter. And this is the spectrum that we can observe through the atmospheric windows. And the atmospheric windows are defined by the content of water vapor that is in the line of sight. Because the molecule of water absorbs the microwaves and in particular submillimeter, so below 1 millimeter, which is, you can see here, for example, this white part is because we do not have receivers here. That wouldn't make sense to have a receiver on the ground because there is no transmission here and here. So we center our receivers, the number from 1 to 10, in the what we call the atmospheric windows. So the most important part here is that we have practically 93% of the spectrum above 100 gigahertz. Only 7% of the spectrum is below 100 gigahertz. This is a table of all the receivers and all the frequencies. And I mean, the most important point is it starts at 35 gigahertz and ends on almost 1 terahertz. And to keep in mind, we also have the post-detection frequency band, which is what you call the intermediate frequency. And this one is in the range which is much lower, between 4 and 12 at the moment, but will be upgraded soon to up to 18 or maybe 20. So, the ALMA site has natural shielding from emissions because it's far away from urban areas and also a 5,000 meter high. So it's somehow naturally protected by human activities. And it is 30 kilometers from San Pedro. Sorry, yes. And the place where ALMA is located, the ALMA site, it has been given to from the government of Chile in 2003, and then later on there was another concession of site which is surrounding ALMA. So I will show you now. This is the dark area. This is the ALMA concession. This belongs to ALMA practically, and whatever is around inside the other white box This is the so-called astronomical park of Atacama, which belongs to the CONICET, now called ENIT. And this is just to see geographically where we are. We are in the second region of Antofagasta, here in the north of Chile. This is a different picture, just showing the urban areas in the close by. This is San Pedro, it's 47 kilometers away, in line of sight. And this is Toconao, the next very small village here. And this is an interstate. So this is a road that goes to Argentina, actually, from Chile. And so there is heavy traffic here. There's trucks and so on. And it's very close. I mean, it's just 10 kilometers from our site. So still talking about the ALMA site. So there are several other telescopes also operating there. And I have a list here. Oh, sorry. I have a list of names. With the exception of the TAO, which is the Tokyo Atacama Observatory, all the other telescopes you see here, these are all radio telescopes. And most of them, with the exception of APEX and ASTE, these are cosmology observation, experimental cosmology, so are very sensitive continuum detectors. And this is connected to what Chris Dupree was mentioning, that we don't know exactly what is the, Mike Peel was mentioning this, what is the thermal body emission of these objects, because there could be an effect. And just to mention it, I was motivated by this from yesterday's talks, that Chanantor is a Kunza word. Kunza is the language of the indigenous Andean people, and means the place of departure to the sky, so it's a perfect name. And so I like to add this slide yesterday about the way the indigenous people, they were looking at the sky. The sky is so dark in the north of Chile, at least it was when the people, a few centuries ago, that they defined the constellation based on the dark clouds that they could see on the bright background of the galaxy. So they were using the Milky Way as a bright background, and they were identifying objects. So they were calling this one, yes, the llama, and then there was the baby llama here, and so on. There is a fox here. So the constellation of these indigenous people was based on the dark clouds, not on the stars. And anyway, these dark clouds practically now are object of study of ALMA. Okay, so the ALMA site is somehow regulated by the authority for telecommunication in Chile, which is called SUBTEL. And there is an XM resolution that it's renewed every 10 years, and we get two zones, two areas. One is a protected area, which is 30 kilometers around the site. And the other one is a coordination zone, where we are somehow in contact with SUBTEL. Eventually, if there is a new application for some emissions in the area, they contact us and we evaluate together the possibility to put some hardware there. The problem is here that, as you can see, it's within the national territory. And if you look at the map, this is the protection area and this is the coordination area. This is Bolivia, and this is Argentina. So, this is within, Bolivia stays within the protection area, and Argentina inside the coordination area, which means that if the SUBTEL can protect us within the national territory, these areas here are unprotected. So, and this is probably could be a risk of radio frequency interference if we don't have any agreement. At the moment, there is no agreement between Chile and Bolivia and Argentina to extend the protection of these areas in Bolivian and Argentinian territory. And of course, so making a list of what are the potential risks of RFI at ALMA, this is from the ground, of course, but then, as we well know, there is a risk of RFI from the sky. And we have been dealing for quite a long time with a satellite which is called CloudSat, which is it's an active service, so practically Earth exploration with a radar, which is called cloud profiling radar. It's 1.6 kilowatt and has 10 dB antenna, so this is very powerful, and if by chance it could happen that the main beam of the radar, it matches the main beam of antenna, ALMA receiver, it will burn the receiver right away. So it's very dangerous. So what we do, we park the antennas when we know that the satellite is crossing. I have a software, a Python script that just calculates regularly based on the TLEs, where is the satellite, and we just take care of this. It crosses roughly every 8 days. So it's a bit annoying, and then there will be a new mission. This one very likely will be decommissioned by the end of the year, so finally. And EarthCare, which is the replacement with coming, there is an agreement to avoid this problem. So practically they agreed to switch off, actually they won't switch off the radar, but they will reduce the power for 3.5 seconds, and 3.5 seconds for the satellites, for the footprint on the ground, it will move by 30 kilometers, so practically goes from one side to the other of the site, and this will be safe. And then there is another problem. Yesterday, this is also motivated by yesterday's talks. I added this part about space debris, because there is a very nice paper. I suggest to have a look at this. And this paper made a model and then calculates what is the impact of the sky glow, they call it. Sky glow practically means that the brightness of the background is increased by, they measure something like 20%. And this is due simply to this cloud of junk, space junk, that is reflecting the light of the sun. Whenever we look at the sky, especially when you look at the zenith or when you look close to let's say, to some angles, there are some specific angles where you get the reflection. And this means the sky is not black anymore. And then I wonder, what would be the radio sky glow? As I mentioned earlier, we always think about the visible light, but I mean, there is a lot of other frequencies that we are not considering when we look at the sky with our eyes or with the optical telescope. So there could be an effect, because this is wavelength dependent or frequency dependent. So what is the effect on infrared? What is the effect on UV? Okay, we don't see UV from the ground, but for other experiments. Or what is the effect on the radio? We don't know. And now let's move to other satellites. So what I showed before was something that is orbiting, but is not satellite constellations. And now for the satellite constellation, this is just a schematic for people who are not very familiar with how the system works. So but the most important point here that we have a gateway station and we have the user terminal. 3 minutes? Okay. No, I will never finish in 3 minutes. Sorry.
I'll make you.
So, okay, so I try to accelerate a bit. But the most important thing is that we have 4 types of emissions. 2, they are from the gateway station to the sky, to the satellites, and the other 2, they go from the satellites to the users' terminals and to the gateway station. User terminals are not a big deal, but the gateway station are a problem for me. And the downlinks, especially to the gateway station, can be dangerous for ALMA. And now I will talk about constellations, and I will show some numbers of frequencies for these 6 constellations, with generation 1 and 2 of Starlink, and then OneWeb, and then Amazon Kuiper, Kepler, and Space Mobile. This is very important. I want to mention that we always think about Starlink as the impact of this constellation, but keep in mind that there are many more satellite constellations, many more. Practically, this is a schematic where the constellations are divided by 1,000. Whatever is above 1,000 satellites is considered to be a mega constellation. What is below 1,000 satellites is a large constellation. Well, there are 44 large constellation planned and 18 mega constellation planned for a total of 549,542 satellites. In operation, we have only 1% of this. And Starlink, the total of Starlink present and future, it's only 6.25%. So the remaining 93.75% are other operators, not Starlink. More than 90% is other operators. So don't think it is Starlink only the problem. I mean, we have other problems. So these are the frequencies now. I will go a bit quickly. And what I want to show here, this is generation 1, generation 2, and OneWeb. OneWeb is safe. So what is green is the uplink. So for us, it's safe. And what is red is the downlink. It can be dangerous. And I divided for user terminal and for gateway station. The user terminal, they're all clean for us. But the gateway station downlinks, there is this one that falls in ALMA band 1, and this one falls in ALMA band 2. And moving on, this is a Kuiper, this is a Kepler. These are fine for us. And, but this one, the Space Mobile, which is a GSM service for standard telephones, it falls again in ALMA band 1. So this is going to be a problem if this is starting to work and if there is a gateway station close to ALMA. This is a schematic of what is the impact not only on ALMA, but also on the cosmology radio telescopes that are at the site. So the forest of lines, luckily for us, falls in this range of frequencies, which is below 20 gigahertz, which is a problem for other radio telescopes, as Chris Dupree was showing. So for SKA or for GBT, VLA, this is the major problem. But for us at the China and Toro site, mainly we have only this problem with OneWeb here with this one channel of the Simons, and then there is this, as I mentioned, generation 1 and generation 2. They fall in the ALMA band 1, but also Simons and class. And here is ALMA band 2, which is affected. And the CloudSat at the moment is affecting ALMA and class and Simons. But this is probably going to be decommissioned soon, hopefully. So, right, this is just sort of a summary. And what I wanted to say is that the problem we have here is that we can talk to the, actually we are talking with the operators, but they decided to do not offer the service over the ALMA site. And they do not offer the service, but this doesn't mean that they switch off the transmission. Actually, we did the test. We put ALMA, a Starlink antenna at the site of 5,000 meters, and we got the signal. So this means the satellites, they are streaming the data at the site. But as I mentioned, this is a low frequencies for us. This is the gateway stations in Chile. There are 7 stations. The highest one, the northest one, is a Caldera, which is 540 kilometers for us. So this is the footprint of the downlink to the gateway station is a single antenna beam. So it's a large, 900,000 kilometers, depending on the angle. So as long as we are far away, at least 500 kilometers, this is safe. So one thing that we are trying to avoid is to put gateway station close to the ALMA site. This is the, I think Mike was showing this, right? Was showing the Blue Walker 3 image on the sky. And this is in a lab. This is Blue Walker 3 when the antenna is deployed. This is 64 square meters as a phased array. But they are they are planning to build 243 satellites, even larger than this. They're planning like 120 square kilometers. So this is going to be a major problem, right?
I'm sorry, but
yes, we have to stop. Yeah, okay. Can I just quickly go through the synergies? Yeah. Because I wanted to mention that we are collaborating with ClioSat, which is an initiative in Chile, led by Jeremy Triglow-Reed. And this is important because just now, as was mentioned by Mike, this paper was being published. This is the same plot that it was showing. And this Blue Walker 3 satellite has been measured up to 0.4, magnitude 0.4, which is a very bright star, right? And then we have also collaboration with the SOCIAS Radio Committee, where we try to evaluate common issues for different observing sites in Chile. And we are planning to develop a refined measurement system which will be similar to the one showed by Chris. And of course, we are in contact with Subtel, this authority for telecommunication in Chile. And finally, we talk with Atacama Astronomical Park to deal with the other telescope. We try to find common goals at the site. and international collaboration with Chris Depri with the NRDZ. And I hope one day we get one of these measurement systems and we can put it at the ALMA site. Okay, I stop here.
Thank you very much.
Sorry for taking more time.
No worries. If you have questions for Giorgio, there are already a bunch of them on Slack. Please answer them on Slack if you don't mind, and please post them on Slack as well.